Happy Friday, ambitious readers. It's January 23rd, and we've got a really big idea in store for you this week. So let's jump right in. This week's big idea: context is king, and you've got to protect it at all costs. Now, every AI demo that you've ever seen has the same hidden dependency: a box of text that the underlying LLM can hold in its mind at once. That box is the context window. And you can think of it as the model's working memory at runtime. While models learn an enormous amount during their training runs, at runtime, they can only condition on what fits into that current window, which has to include the system prompt, your messages, tool calls, documents, custom instructions. All of it are competing for the same space. And if it's not in that window, it's not reliably in play. Now, if you feel like the pace of AI development is dizzying, you're not alone. Agents, skill libraries, sub-agents, model context protocols, tools, plugins, the Ralph Wiggum loop. Yes, literally, the character from The Simpsons is playing a role, and it is a lot to keep up with until you realize that most of it converges on the same problem: protecting and compounding the context window. And that pressure is turning into a discipline. Now, software development, it may be getting easier. Even people like myself can develop software, as evidenced by last week's edition. But the harder work, the new software engineering, it's protecting and compounding this context across time, tools, and workflows so that you're not sacrificing reliability, security, or clarity in the system that you're ultimately producing. And there's an arms race in the size of this context window. For the past 2 years, model providers have competed on context window size the way that cloud companies once competed on storage limits. The state-of-the-art models, they now support 1 million plus token context windows. In plain English, you can literally hand the model a small library, and long context expands what is possible. But bigger memory does not eliminate the hard part of deciding what matters. And the reason for that is that researchers have documented a frustrating pattern in very long context models. Performance degrades just by moving the relevant information around. Models often do best when the crucial detail sits near the beginning or the end, and they do worse when it's buried in the muddled middle. This is referred to as context rot, which is a catch-all term for performance degradation as prompts grow longer, more crowded, harder to search. Long context is necessary, but long context can still produce brittle behavior if the model cannot reliably use what you've provided it. It is no longer how many tokens can I jam into this thing. It is becoming, how do I curate the right tokens at the right time? Enter context engineering. This is the iterative practice of selecting what should go into that limited context window for an expanded universe of possible information. And once you see the context window as a scarce resource, many of these innovations that you are reading about stop looking like separate ideas. Tools and plugins and MCPs and skill libraries and orchestration loops, they are all variations on the same theme. Preserve the window for judgment and push everything else out. And I want to give you a simple mental model of 5 of the most important innovations that you are likely hearing about, starting with tools and plugins, which give you reach. The model doesn't need to try to be a browser or a database. If those are existing systems, let the model call them. It'll keep your conversations lighter and tighter. Model context protocols, or MCPs, act as plumbing, and they give agents a standard way to connect to external tools and data without turning every single one of those integrations into something you have to include in the prompt. Skill libraries, which we've talked about a lot already in 2026, those are reusable playbooks packaged for an agent. Instead of pasting in the entire standard operating procedure into the prompt, let the agent load those instructions when it needs them. Now, our friend Ralph Wiggum from The Simpsons, orchestration loops. These are long-running work that stay grounded in the context that you're giving it so that you don't have an endlessly growing chat transcript. And the way that these orchestration loops work is that they refresh the context window after they're done with a particular task and recenter on a current source of truth. And finally, retrieval and summarization, where you are selecting, then compressing. By pulling the documents that matter, summarizing them into something the model can use, and moving on. These 5 innovations, they all have different names, but they have the same objective. They're treating the context window like a budget, and they are spending it on the highest value decisions. And the reason they're doing that is because when context is high quality and well structured, the AI produces excellent output. When context is noisy or inconsistent, less so. As we used to say early in my career at IBM, garbage in, garbage out. And while software development may be getting easier, perhaps it's getting cheaper. Software engineering is evolving. It's redefining. The bottleneck is no longer the technical skills to write the code. It is the discipline, the art, the science of assembling the systems that preserve, protect, and compound context. And by doing that across different time periods, different tools, different agents, different workflows, and orchestrating all of these things in harmony to deliver production-grade software. And some of us are starting to refer to that as context engineering. And so the real craft of building AI agents in 2026 looks something like this: deciding what must be in the window, and then deciding what should live outside of it in tools, plugins, files, skills, building mechanisms that load the right context at the right time, and finally, having the discipline to keep the working set as clean as possible, ideally with a good plan. In other words, the context window is becoming what RAM was to early computing. It's the scarce resource around which the entire system organizes itself, at least for now. And to me, this feels like the future of software engineering, and I don't think we're going back. I hope you have a wonderful rest of your week, ambitious readers. It is my supreme pleasure to be with you every single week. I look forward to being back with you again for our next edition of Reading Ambitiously. Take care of each other.